Okay, good day, grade 8. I trust that you are well. This lesson serves as a revision lesson to prepare you for mathematics paper 1. So some of the sections that is included in maths paper 1, right? It's including but not limited to whole numbers, right? So whole numbers will be in the paper. Remember, whole numbers include financial maths, it includes rates and ratios, it includes finding the HCF, the LCM, etc. There's also common fractions, right? Decimal fractions, integers, and there's one more, exponents, right? Which is quite a large part of the test as well. Right, so these 5 subtopics make up section 1 of your mathematics final exam. So this lesson is just a recap or revision lesson, if you will, that will prepare you for this paper. So let's get started with that. So let me clear this page. Let's start off with whole numbers. Now, there's 3 properties of whole numbers that I would like to mention. The first property is the commutative property of addition and multiplication. So let me spell this right. Commutative property of addition and multiplication, right? So what is the commutative property of addition and multiplication? Basically, this means that if I have a value like a plus b, it is equal to b plus a. I can swap the values around and they're still equal to each other. Now, I want you to think of a practical example. For example, if I have 2 plus 3, which is equal to 5, it is the exact same thing as 3 plus 2, which is also equal to 5. So that's the commutative property, and it applies for addition and multiplication as well. So if I have a times b, it is the exact same thing as b times a, right? Very important. For example, if I have 2 times 3, which is 6, it's the exact same thing as 3 times 2, which is also 6. Then the next property of whole numbers that we can look at is the associative property. Now, if you think of the word associative, I can clearly see the word associate, right? And again, this is associative property of addition and multiplication. I can see the word associate in it. And what does the word associate means? If you associate in with a group of friends, that's what it is. It's a group of friends. So if I have a plus b plus c, it is equal to a plus b plus c. And what happens if I group a plus b, and then if I group b plus c? This is equal to each other. Now you might say, I don't believe you. So let's test this out to see whether this is true, right? Let's say I have 1 plus 2 plus 3, and I group 1 and 2. So according to BODMAS, which you should know, brackets of or order, division, multiplication, addition, and subtraction. The general rule is that addition and subtraction comes, sorry, the golden rule is that division and multiplication comes before addition and subtraction. So we do that first, division and multiplication. So 1 plus 2, if I use BODMAS, 1 plus 2 is equal to 3, 3 plus 3 is equal to 6. And what happens if I group the 2 and the 3? Let's see what happens here. What happens if I group the 2 and the 3? Right? Going to BODMAS, 2 plus 3 is 5, 5 plus 1 is 6. So that is the commutative property of addition. If I look at the commutative property of multiplication, if I have a times b times c, and if I group a and the b, it is equal to a times b times c, and I can group the b and the c. So that is the commutative property and the distributive property. The next property that we will look at is the distributive property of multiplication over addition and subtraction. Right, so this is quite simple. Right, let's look into it. Right, so the distributive property, right, the distributive property of, and it has a long story of multiplication over addition and subtraction. Basically, it means that if I have a value that's outside of the brackets and it's been multiplied to that brackets, so for example, b plus c minus d, it is equal to, I need to take the value that is outside, that's attached to the brackets, and distribute it, multiply it to every term that is inside the brackets. So that is equal to a times b, which in terms of variables, ab means a times b, plus, I use the same operation, plus a times c minus a times d, right? So those are the three properties that we looked at. There's also other terms as well that I want to discuss with you. And this also falls part of whole numbers. Right, so let's discuss this very quickly. Right, so the first term I want to discuss with you is something called rational and irrational numbers. Now, you might have heard about these terms before. Rational and irrational numbers. Very interesting. Right? A rational number is a number that can be expressed as a fraction. So if you enter it into your calculator and it gives you a fraction, like for example, if I enter 0.5 in my calculator, it will give me 1 over 2. So therefore, it is a rational number. 2, the number 2, is a rational number because it's 2 over 1 if I have to express it as a fraction. So a fraction, they are numbers that can be expressed as a fraction, right? What about irrational numbers? Irrational numbers, of course, if rational numbers mean that they can be expressed as a fraction, irrational numbers is basically the reverse. It's numbers that cannot be expressed as a fraction. It's numbers that cannot be expressed as a fraction. Right? So that's the difference. So for example, let's look at a couple of examples. Pi, for example, which we looked at in paper 2. But pi, which is an irrational number, why do I say it's an irrational number? Because I cannot express pi as a fraction. But if I take another, let's say, I'm trying to think of another, let's say the square root of 3. If I enter the square root of 3 in my calculator and I press SD, it gives me 1.73205, and I press SD again, it cannot be expressed as a fraction. Now you might say, but Mr. Jordan, what if it's the square root of 3 over 1? And that's actually quite a good question. But in terms of a rational number, it has to be, let me use another color so that it looks better. It has to be an integer over another integer. Now, what is an integer again? An integer is all your whole numbers, which is 0, 1, 2, 3, all the way to infinity. It's all your whole numbers. It does not include any decimals or fractions, and it includes your negative numbers as well, all the way to negative infinity. Again, no fractions or decimals, in the sense that there's, like, for example, negative 2.5. That cannot be an integer. So since the square root of 3 is not an integer, the square root of 3 over 1, of course, that's also not an integer as well. So I just thought that will be worth mentioning for revision as well. Now, that being said, let's look at more examples. Whole numbers includes ratios. Ratios is basically a comparison between two things. I'm trying to look for this thing. Right? It basically includes a comparison between two things. Okay, so let's look into it. Let's look at ratios. Right? Let's say Tom has 300 Rand. This is an example, right? He wants to increase 300 rand in the ratio, right? He wants to increase 300 rand in the ratio 1 is to, sorry, 2 is to 5, right? So if he wants to increase this amount, that means that 300 rand is currently is represented by 2, and we need to find the value of 5. So the golden rule of ratio is divide by what you know, multiply by what you want to find. So it's going to be 300 divided by 2 multiplied by 5, which is equal to 300 divided by 2 multiplied by what you want to find, which is 750 rand. So if I want to increase 300 rand in the ratio of 2 is to 1, it will be equal to 750 rand, right? Also, something just popped up in my head right now, so just a random thought. If I say 3, I don't really like this, it's a bit dark. If I say 3 over 0, what value is this, right? I can enter it into my calculator and it will say math error. 3 over 2 is known as an undefined value, right? If I have the square root of negative 1, that is known as an imaginary number. It's unreal or non-real, right? It's a non-real number. I thought this is actually quite worth mentioning, because if any number is divided by 0, it's going to, of course, be undefined. So just bear that in mind, right? And right, okay. So that being said, fractions, of course, will obviously be in the test as well, and because quite a large part of term 1 dealt with common fractions. Golden rule of fractions is just to ensure that your denominators are the same, especially when you add in or subtract in fractions. For example, if I have 1 over 2 plus, let's say, 5 over 2, because the denominators are the same, it's going to be 1 plus 5 all over the common denominator of 2, which is equal to 6 over 2, and always simplify your final answer. So 2 divided by 2 is, sorry, 6 divided by 2 is 3. But what happens if the denominators are not the same? So if I have, okay, I'm using 1 quite a lot, so let's say I have 2 over 3 plus let's say 3 over 5, this is an example, right? Because the denominators are not the same, I need to find the LCD, which is basically the lowest common denominator between 3 and 5. So the lowest common denominator, if I have to list out the multiples of 3, which would be 3, 6, 9, 12, 15, 18, and so forth, 21 and whatnot. If I have to list out the multiples of 3, and if I have to list out the multiples of 5, I'll see that the the lowest common denominator, 5, 10, 15, 20, etc., will be 15, right? So what I'm going to do is I'm going to multiply both fractions by 1, and in this case, one number multiplied by 3 would give me 15. It will be 5. So 5 over 5 times 5 over 5. So this is equal to, remember, we multiply fractions top at the top, bottom at the bottom. 5 times 2 is 10 over 15 plus 15 over, oh, sorry. Right, you can see I'm just making mistakes like crazy. Okay, so remember, what multiplied by 5 will give me 15. Of course, that'll be 3. Silly mistake that I made, right? So I multiply this fraction by 1, which will be 3 over 3. Apologies for that. So now I multiply top at the top, bottom at the bottom. 5 times 2 is 10 over 15 plus 3 times 3 is 9 over 5 times 3 is 15. And at this point, because the denominators are the same, my answer will have that common denominator of 15. So it will be 10 plus 9, which is equal to 19 over 15. And if I can simplify that, that'll be great. If I cannot, then it's just 19 over 15. And that is my final answer. Now, common fractions also link quite well with decimal fractions link quite well with common fractions. And let me show you what I mean by that. So let's look at this example. Right? So please go over common fractions. It's quite interesting. Remember, when you multiply two fractions, it's always top of the top, numerator multiplied by numerator, denominator by the denominator. Remember, when you divide fractions, you KCF, you keep the first fractions, you change the division to multiplication, and you flip the second fraction. Basically, you find the reciprocal. But this is actually quite interesting. Let's say we are required to simplify the following. Right, I have 0.2 divided by 1.5. Right, okay, let's make it 0.45 plus 0.25, right? So this is what we call a decimal fraction. I can express it as a fraction which has a denominator of 10 raised to some power. There's one digit after the decimal comma, right? And we this is content from term 1, by the way. There's one digit after the decimal comma, so the denominator will be 10 raised to the power of 1, which is 2. Divided by, there's two digits after the decimal comma, so it's going to be divided by 10 raised to the power of 2, which is 100. And the numerator is 45, plus, and if I look at the last fraction, it's 25 over 100. Now, remember, according to BODMAS, I have to look at division first before looking at addition. So let's calculate this. This is equal to 2 over 10, right? I'm going to keep the first fraction, KCF, because I'm dividing two fractions. Keep the first fraction, change division into multiplication, and flip the last fraction. So it's 100 over 45 plus 25 over 100. Now I can multiply top of the top, bottom of the bottom. 2 times 100 is 200 over 10 times 45 is 450 plus 25 over 100, right? So let me just move this up so you can see what's happening. Okay, so let's continue from here. Now we need to look for the lowest common multiple between lowest common multiple between these two denominators, so we're going to call it the LCD. Now let's just think on the side here for a minute, right? To find the LCD, I'm going to say 450 is equal to, now I can use the ladder method to find 450 as a product of its prime factors. So actually, I would like to do this with you now. Let's rewrite it as a product of its prime factors. So we're going to use our ladder, 450. Remember, prime number is a number that has two factors, 1 and itself. The first prime number that can go into 450 is 2, which can go into it 225 times. 225 divided by 3, 3 is a factor. So since 2 is not a factor, 3. So you need to have a good eye on the factors, the prime factors. It's 2. 2 happens to be the only prime and even number. 3, what else? 5, 7, 8, no, 9, no, 11, 13, and so forth and so on. So you get the point, right? And so let's use this guy. So since 3 is not a factor of 225, it leaves a remainder. 2 leaves a remainder, so we need to try the next prime number, which is 3. And that goes into it 75 times. Now, is 3 a factor of 75? Yes, it is. It goes into 75 25 times. 2 is not a factor of 25. 3 is not a factor. 5 will be a factor. 5 can go into 25 5 times, and 5 can go into itself once, right? So I actually wish I had more space here, but so 450 is equal to 3 times 2 times 3 squared times 5 squared, right? As such. Okay, now that being said, let's look at the factors of, let's rewrite 100 as a product of its prime factors. So just to save some time, if you do that, if you rewrite 100 as a product of its prime factors, you will get, sorry, let's get this color right. You get 100 is equal to 2 squared times 5 squared. So to find the lowest common multiple, which will be the lowest common denominator, I look at the two 2's. Which 2 has the highest degree? Is it 2 or is it 2 raised to the power 1? It's 2, sorry, is it 2 squared or 2 raised to the power 1? It's 2 squared. Then I look at 3. There's only one 3 here. There's no 3 that is here. Technically, there's a 3 raised to the power of 0, which is 1, but we do not count that. So, of course, 3 squared will be larger than 3 raised to the power of 0. And between 5 squared and 5 squared, I can just select any one. So, my lowest common multiple is going to be equal to 2 squared times 3 squared times 5 squared. Right, so this is going to be quite a large number nevertheless. So times 3 squared times 5 squared, and that is going to be equal to 900. Right, that's the lowest common denominator between the two. So what do I need to multiply 450 by to give me 900? I'm guessing it's going to be 2, so I'll multiply this fraction by 2 over 2. I'm not changing the value. When you multiply anything by 1, it's still that value. Multiplied by, what do I need to multiply 100 by to give me 900? I need to multiply it by 9. Now this is quite a large fraction. So it's going to be equal to 2 times 200, which is 400 over 900, plus 9 times 25, which is 225 over 900. That's equal to 400 plus 225, which is 625 over 900, right? And that is the amount that we currently have. And now we can simplify that. So when you simplify that, it's equal to 25 over 36, right? So that is the value that I have. Okay, so in this case, it's fine to leave it as a fraction, but usually, because the decimals are quite large, but usually it will be nice to, when you have a problem that involves decimal fractions, it's best to leave your answer as a decimal, right? So that was that. And just to show you what I mean by the last statement I made, let me show you an example of that, right? So let's say we have 0.25, let's say we multiply that by 0.4, right, just as an example. So this is 25 over 100. I convert it to a fraction, times 4 over 10. That is equal to 25 times 4, which is 100 over 1000, right? So in this case, it's going to, now we can convert this into a decimal, right? So of course we can simplify it. It's going to be 1 over 10, and 10 which basically means that it's going to be 0 point, and there's going to be one digit after the decimal comma, in this case the numerator, which is 1. So we leave our answer in a decimal form, right? Now the last example that I want to discuss for today is actually quite interesting as well. Okay, so let's look at the last example that I want to discuss. Let's say I have a square. Now let's not say a square, let's say a rectangle. Right, let's say I have a rectangle, right? And this rectangle, right, or let's say I have a rectangular box and I have two portions of the box. There's one portion and there's one portion that's here, and there's another portion on the right hand side. Let's say this portion is 75%, and if that portion is 75%, you can tell me what's the next portion. The other portion, of course, will be 25%. This is 75% to 25%. Let's say the area of the box is equal to, right, let's say it's equal to 500 meters squared, and I want you to tell me what is the area of the shaded part. What is the area of the shaded part? Right? So if I have to ask you what is the area of the shaded part, it's going to be 500 meters squared times 75%, because 75% is the shaded part, which is, so the shaded part is 375 meters squared. Now if I have to ask you, right, what is the area of the blue part? So the area of the blue part will be 500 meters squared times 25%, or you can just say 500 meters squared minus 375 meters squared, and let's see what is that equal to. Okay. Which is, right, let's get this right. Okay, the mouse just froze. Let's get this back. Okay, yeah, we are back, and that is 125 meters squared. Now, I said this was the last, but actually I forgot. Laws of exponents is a large topic in the paper as well. So you need to know all the laws of exponents. The first law, when multiplying and the bases are the same, we add the exponents. The second law, when dividing and the bases are the same, we subtract the exponents. The law that says when you have a further power, an exponent raised to a further power, you multiply the exponents together. So there's actually quite an interesting example. Let's say we have, for example, negative 2x raised to the power 3y raised to the power 5 times, let's say 3x raised to the power of 2, y raised to the power of 4, right? So in this case, remember, negative 2x raised to the power 3, y raised to the power 5 actually means negative 2 times x raised to the power 3 times y raised to the power 5. And we're multiplying these three values together as well. So what I can first do is I can multiply the coefficients together. Negative 2 times 3 is negative 6. X raised to the power of 3 times x raised to the power of 2 is, now I can apply the first law of exponents, which states when multiplying and the bases are the same, we add the exponents. I keep the common base, which is x, and I add the exponents together. And now y raised to the power of 5 times y raised to the power of 4 is y raised to the power of 5 plus 4. That is equal to negative 6 x raised to the power of 5 y raised to the power of 9, and that is my final answer. So go over all the laws of exponents, especially when you raise an exponent to a further power. Right? It's actually quite interesting as well. So go over those topics, and that will prepare you for section A of paper 1. Okay, I wish you all the best for your paper.